Ora si registrerà la conferenza.
Registry of pollution sources, weather data, and environmental analysis. The Veneto region provides data shapefiles on river basins and irrigation districts, and data on population and PFAS biomonitoring. The Regional Center for Veterinary Epidemiology and the Agency for Payments in Agriculture provided data on crops and farms. And finally, the water companies provided data on drinking water systems. The structure of the information system is composed of two components. The data warehouse, which collects data from multiple data banks, includes at present 54 data flows and 6 geographical data sources, and has a 5-year historical depth. And then there is an online geoportal, which has a multi-layer structure, is organized in several thematic areas, and allows integration of the different data sources and production of various types of reports. So the operative working method, which I already give a link to, was to schedule meetings with each owning entity in order to understand their domain of expertise, define detailed information, define the feeding path and extraction procedures, and evaluate data quality and data cleaning procedures. So the strengths of our tool are that it is a web-based cloud platform, that it has an integrated data warehouse and multi-layer reporting and predictive tools. The weaknesses that we hope we will be able to solve in the near future are that it is a still unstable product and currently it is unable to manage linear shapefiles. We also defined some access rules to our information system. This tool is intended for use by experts belonging to entities with competencies in the fields of environment and health. So it is not for citizens. And so the access is allowed only to users that are formally identified by the entities. We identified 2 levels of access, one basic level for consultation of predefined reports, and an advanced level for consultation and extraction of raw data and development of customized reports. There are also 2 types of reports. There are territorial reports and analytical reports. Here you can see the types of territorial reports. We have a report on pollution sources in relation to river basins, another report on irrigation sources and districts, one report on crops in relation to irrigation districts, and a 4th report on drinking water companies and networks. And now I will show you some screenshots of the first type of report. Here you can see the map of our region, the Veneto region, and the green dots represent, in this case, the wastewater treatment plants that are present in our territory. And these dots are put in visual relationship with the river basins, which are in light blue color, and with municipalities that are in orange color. Here, with this bar on the right side, you can select the type of pollution source. We can also have a multiple choice. Here you can choose filters for specific pollution sources. And in the tables at the bottom of the map, you can see the number of pollution sources by river basin and by municipality. You can also filter on river basin. For example, here I have filtered by the river Sile. And here you can filter on municipality, in this case Rovigo. Here you have some standard functions that allow to export data, images, to scroll, to enable, disable layers, and to have a zoom. With these functions, you can download the data, both in the form of tables and you can choose the format. You can choose the folder where to download data, and also you can download the images. And now let's go to the second type of reports, analytical reports. We have basically two types: a report on temporal series of environmental analytical data, and a report on serum PFAS in the exposed population. So let's see the first type. Here you can see that the image is blank because, first of all, you have to select the metrics of interest, for example, lake water, sea water, river water, drinking water, wastewater, and then you have to select a specific compound. You may also filter, but it's not compulsory, on a river basin and on data source. And here you can see a graph. I have selected industrial wastewater, and as a compound I have selected PFOA. And you can see this box and whiskers plot that shows the concentrations of PFOA in industrial wastewater by year from 2017 to 2020. Then let's see the second type of analytical report. You can see here this report depicts the serum PFAS concentrations in the exposed population of the polluted area of Veneto Region. On the left side image, you can see a map of municipalities in which it is indicated the percentage of tested individuals with quantifiable serum concentrations of a specific PFAS congener. In this case, I have selected PFOS. And on the right side image, you can see for each municipality the predicted median serum concentrations. These predicted concentrations are obtained for a multivariable regression analysis, adjusting for a series of individual variables such as gender, age, number of years of residency in the polluted area, and so on. So the next developments we have in mind are, first of all, to be able to manage linear shapefiles, for example, rivers and drinking water networks. Then to integrate in the data warehouse more health data and statistics, for example, maps of mortality rates and incidence rates. And then the integration of outputs from the hydrogeological forecast models that will be the focus of the second webinar next week. So I thank you for your attention, but maybe I think we have some more time to give a brief online demonstration of the information system.
Thank you.
Just a moment.
Okay.
We have to enter in the online platform.
Perfect.
Lo state vedendo? Ok. Allora, partiamo con l'analitico 1.
No, col territoriale.
Ah, ok.
Now I'm opening the folder on territorial reports. We will select now the first report, which is the one on pollution sources in relation to river basins and municipalities. I hope it is uploading data. Okay.
Dobbiamo aspettare che si carichi qua.
Just a few moments of patience. Okay. Now we will deselect wastewater treatment plants and select local productive facilities. Moments of suspense.
Gisela, do you think that it can be translated also in English or not? You don't think so?
No, I just can comment on what we are doing, but it cannot be. It is not in English at the moment. It's only in Italian. Okay. Okay. Now you can see that the map is occupied by dots because we have selected all local productive facilities, but we are now going to refine the selection with the so-called ATECO code, which is a national classification of productive activities in Italy. And this code, C1511, corresponds to tanneries. Okay, so we know that in the Veneto region we have a tannery district, which is located mainly in the Vicenza province. And here you can see on the map that we have selected tanneries on our map. In the tables below the map, please scroll down. You can see that on the left we have the count of tanneries by river basin, and on the right by municipality. Okay. No, that's all. Now we are going to open one type of analytical report. in this second type of report, you can also visualize on the same map the data on environmental analysis. So you have to select one type of data source. You have to select the year of interest. Let's keep 2019. Then the type of matrix.
Oddio.
Just a moment. Okay, let's choose industrial wastewaters. And then we have to choose the compound. PFBS.
Andiamo.
PFBS here. Ok.
Qua c'è già vicino. Che l'avevo già fatto prima. Ecco.
Okay. Okay, so you have here the yellow dots, which represent tanneries, like in the previous territorial report. And then we have some red dots, which represent the results of analysis, including PFBS in industrial wastewater, that are geolocalized according to the sampling point. The dimension of the dot is proportional to the median of results, while the intensity of red color is proportional to the number of samples. And you can see also the data summarized in the tables below the map. Okay, I think it's enough, and thank you again for your attention.
Thank you, Gisella, for having presented this interesting data warehouse. This is very a crucial point of all the management, the possibility to have data, to share data from all the actors, because this data warehouse will take together data from water producer, from all the department of the Regione Veneto and the agency, and it will be central to take decision also for policymaker, for expert. And now I introduce myself, and okay, can you see me? Yes, can you see my presentation? Okay.
Yes.
Yes, thank you. And I will present you one of the main outputs of the LIFE16 project, that will be a guidance, a manual, a guidance of management that will help in our idea, it could help the policymakers to manage all the events of chemical pollution in the future, with of course with a special focus on the persistent and mobile compounds, and of course the experience has been tested on the PFAS that in our region, in Regione Veneto. Yes, the working group is composed by the people from Regione Veneto, from the regional agency of environmental prevention and protection, and also from the research part of the group, that is our institute, the Water Research Institute, and the University of Padua. That's so we bring together institutional people and research people. That's the key point of this LIFE project, also the key point of this guideline, and also of the architecture of the governance of the problem. The two goals the LIFE16 project is the implementation of a model of governance of the emergency due to chemical contamination of water resources with potential effect on human health. And the focus, as already said, is about the PFAS, but the short chain PFAS, because they are organic, mobile and persistent organic compounds. That's now this kind of definition, PMOC or PMT, persistent mobile and toxic compound, is a key point in the future EU legislation on chemical compounds, because if they are persistent and mobile, you are sure that you will drink these compounds will be drank by you, because if you are persistent mobile, they will spread along all the water resources, and you will find into your glass. That's a key point. If they are, of course, then there is you have to define if they are toxic, of course. And at the end of the month, there will be a very important conference on PMT organized by environmental agency of Germany, and also German university, and that will be an important point to share all the vision about the problem of persistent mobile compounds. And how is organized the governance system for the LIFE project? The pillars of the LIFE16 governance models are the establishment of a structured interinstitutional governance system based on a permanent regional commission for environment and health, which must be supported by interdisciplinary expert groups. The experts and the policymakers should rely on the availability of the integrated information system. You have already seen that, which has been designed to facilitate and support the risk analysis process, especially for both from environmental risk analysis, but also to evaluate the impact of human health. That's because we are taking together, because there is not possible to separate this, especially for this kind of compounds. The acquired data will feed also a predictive mathematical model to forecast the spread of the pollutant contamination plume in space and time. So we need 3 points: a governance system structured, an integrated information system to collect all the data together, and also you have the need for predictive models, tools to predict where the compounds will go, and will be the impact of them. A fundamental condition for the model implementation is this establishment of an effective governance chain, where the role and competencies of the different actors must be clearly defined. That's because in many cases the problems are linked to the fact that that there are some overlapping of competencies and discussion. That's a clear problem in all the politician and all the governance of the problem. And the governance chain is composed by 3 levels. Of course, there are at the top, we have the policy and decision makers, the politicians, but they have to be supported in their decision by a permanent regional commission for environment and health, which includes all the government institutions with all the operative agency, that must carry out integrated risk assessment, elaborated mitigation actions to be submitted to the policymaker for taking decision. Because if you have not a strong scientific support, the decision cannot be funded. They are only taken from the people, from the sensation. But this permanent commission must be supported by a multidisciplinary expert panel, which gives their scientific consulting starting from the available data. And that's, sorry. Okay. The fundamental condition among the key points, one point is very important to define the clear identification of which government institutions are responsible for the prevention and management of different aspects of contamination. And also we have to define which technical agency could give support to a government institution in implementing prevention and management plan. That's in this Veneto experience, the main topics, the main field that we have to cover are the sanitary, the environmental, and agriculture. But also there are also a problem of the cycle of waste, for example, and all the management of the waste, the dump site, and also the industrial part, and that's are very important. But they have also to be supported by the people that have the competencies of statistical and demographic data, because of course in the region this is very important, as we saw in the data warehouse. And we have to assure that competencies and roles are clearly defined, but also we have to establish clear communication plan, because we need to establish rules and procedure for assuring a regular and systematic communication among members, both of the permanent commission and between the experts and the regulatory institution. And in the governance system, of course, it is central to establish a common data warehouse that is a shared database. We have seen then for collecting and analyzing all available data in an integrated way in order to define sources, to assess the environmental and health risks, and also to forecasting scenarios. That's very important, because decision could be taken against the scenarios that we think that will happen. The characteristics and the functionality of the data warehouse, of course, has been clearly presented by the previous speaker. And about it's important also that the integrated analysis of available data constitute the basis for the development and the application of predictive mathematical models to understand, for example, the 3D flow and transport in the groundwater, in this case, to understand and predict the qualitative and quantitative process, also degradation process or absorption process of the contaminants. But especially we need to evaluate, should evaluate the site-specific interaction between contaminants and the soil, the specific site-specific characteristic of the soil. And together with the predictive mathematical models, we are in fact during the LIFE project have a specific action to calculate, for example, the KD, the partition between the PFAS family and a series of typical soil collected into the ground, the area impacted by the real area impacted by the PFAS. It's very important that this predictive model will be presented on the next webinar on the 3rd of March by colleague Mazzola from the ARPAV, from the regional agency that developed it. And so I invite you to if you are interested to be present. And one of the key point of all the LIFE project are the transferability, and the tools to transfer has been identified in two documents: the self-analysis checklist and the management guidelines. And about the self-analysis checklist, this document is developed as a checklist for all institutions and policymakers which we would like to implement the management model developed under LIFE16. It is designed as a tool to help institutions in assessing their own capacity to implement the model and to identify any gaps that needs to be filled in. This is like a questionnaire that I have that or not. We need that or not, or it's necessary or not. And the checklist summarizes for each action into the project which baseline condition and which case steps are necessary to guarantee a successful implementation. The second document that we will be produced at the end of the project is the management guidelines. The preliminary version will be completed after this kind of sharing of technical meetings, and the final documents will be structured including all the key deliverables, but in a form that are not, but in a practical form. That is, at the end, for example, of these documents, we will also have some example of application. And it's important that we will define. We have already the draft, and we will complete the document within this March. So it will be made available by the website of the project, LIFE16. Now the index are clear, divided in four modules. One, governance operational tools that include all the institutional, the governance chain, the monitoring plan, the socioeconomic impact assessment, and also we have the second module that is included all the tools, mitigation tools that we have developed under the project. And for example, in the last webinar on 10th of March, we will have a presentation on phytodepurration that we tested in natural field the possibility to use phytodepurration for irrigation water mitigation. That's a big problem. We have also a module on forecasting tool and early warning. That's another point very important in the prevention, because but not done apart. From a part, there is the need for prevention, and all the systems are organized to prevent the contamination. But if the contamination happens for that accident, for example, we need an early warning system to be able to intervene in emergency. And also very important, the communication plan. That's at the end of the project. As I already said, we have some example scenarios about, for example, the accident with the release of a kind of persistent mobile compounds into the environment, for in this case a known pressure source, for example, an industrial site or a waste management place site. in this case, a central role in all the processes, the query of the database, because it is useful to identify the physical, chemical, toxicological characteristics of the released substances, and also the available data should help to identify the sources, the pressure and the territory and the sources that will be confirmed by, of course, a specific investigative monitoring campaign. And the key information should be fed also in the flow and transport models in order to identify the potential targets, the possible threshold levels that will be get by the product, and the future evolution of the pollutant diffusion. And that's very important. By these scenarios, the forecasting capability is crucial because it's helped to define the potentially exposed population. That's a very fundamental part of the management of the governance, because of course people want to be protected. We have to define clearly who is impacted, who is to be subjected to a sanitary protection, a sanitary monitoring, and who is not impacted. And also to plan implemented the mitigation measure, both at emergency level but also at a long-term levels. The last element to be implemented is the operational and surveillance monitoring plan. It is important to define whether any existing monitoring networks are sufficient or need to be integrated with more sampling point, more frequent monitoring to track the spread of the contaminants and evaluate the effectiveness of the containment and mitigation measure adopted. So this is more or less the big scheme of the management guideline that they will, as already said, will be available at the website of the project, www.life16.eu. Thank you for your attention, and also I invite you to visit Treviso when it's possible to see this very beautiful chapter hall with all these nice monks that are reading, writing, and writing guidelines and so on. Thank you for your attention. Okay. If of course there are questions, we can. You can maybe. Sorry. Okay. The next, if there are questions in the chat or not, Giselle, have you read the chat? There are
I don't know, maybe there is a question from Vito, okay. Belgium. Would the governance system developed in Phoenix be useful as a basis to set up an EU-wide early warning system, as is currently piloted in a project commissioned by the DG Environment?
Yes, that's a question for you, but for you that are institution. But I think that the need is to at the moment that the regional institutions are not really connected between the member states, are connected by the European Union, but also we have problem connected different regional in many also in many federal states. Also in Italy we are not federal, but we have some autonomy in the regional, and so it's clear that there is some problem of communication. In my impression, that you can confirm or not because you are inside the regional institution, but there are many problems of sharing and connecting between the region inside the countries, but of course between the region inside the Europe. And maybe we have to stress to enforce the connection between the regions, that are not only between central member states. That would be a key point to have, because of course these compounds move by by rivers, moved by air, and there is no, and they are a global problem that cannot be managed only at a regional basis. And I think that all the action, for example, also important, all the program of, for example, I don't remember. Yes, the project that between regional that are developed by the EU are very important. All the action that will be supported to share data, to share capabilities between regions should be supported in this case. What do you think, Giselle, about that?
Sorry, can you repeat the last question, because I was watching the chat.
You think that there is a need to more integration between region inside the countries, but also within the different countries in Europe, not only at state level, but also at regional level.
Yes, I think so, for sure. And I think we also need more integration inside each region between different entities of different disciplinary areas, such as health, environment, and so on. And I hope that this project will be only the starting point of this integration work.
Okay,
Excuse me, can you mute the microphone? Who is not speaking?
I can do that.
No, there is some radio in the background.
I cannot do that. Okay, if there are no other questions, I pass the floor to. Sorry, I have to look for the. For Luca, okay, it's a great pleasure to introduce Luca Lucettini from environmental, also the Health Institution, National Health Institute of Italy. That presents the integration of data in health, environment, and climate issues. That's the problem of data sharing and integration is crucial for all these activities. Luca, I am.
So much, Stefano.
Okay, seeing you the role of. Okay.
Okay, I should on the screen. Please let me.
Yes, we see that. Perfect. You can use the presentation modality. Perfect for us.
Very good. Thank you. And maybe I have to move a little bit down. Okay, and thank you so much for your invitation and for the pleasure to follow the interesting issue, information, and approach you share before my presentation. As usual, it's better to learn that present in a very interesting workshop like this one. So what I'm presenting now, it's already done in your pilot project, and in part the contribution, the information I'm going to present was already used from Veneto to Brussels to the Commission, because what I want to share now with you is the Italian, but also the other member states' contribution in the Drinking Water Directive, that was not only to fix a limit for PFAS or for other emerging contaminants, but the message we tried to pass is to change the culture of prevention into any law and any act in our regulation. So my pitch is more general than before, because you already presented the application, the real practical way to share data and information. Now I'm focusing on why we should do it and how we can do it. We can try to integrate hand and environmental data for prevention actions. The reason is because health is an immediate term and a very simple concept, apparently, because it's part of the priority of our life and development, but really it's a very complex result of many determinants. It's a right. It's a right for everyone. We need this involves equity, and it's not only the absence of disease, but it's also well-being, and this means cooperation, development, and many other things that go around the concept of health. And if we think that why health specialists are interested in environment and climate, this is very simple, because environment affects health. Maybe for one quarter, 25% of determinants of health are due directly
Luca, non si sente nulla.
Ah, sorry. Could you listen better?
Yes.
Yes,
Okay.
we have come back to the previous slide. We have not.
The previous slide. Yes.
This concept is very easy. Why health specialists are interested in environment and climate? Because environment affects health. More or less, for one man out of 4 men can have a serious disease from environment and climate. But on the other hand, health is not only affected, but is a determinant of development and life. And this concept is that health is the priority to have any kind of life and development. And we are now living this in this pandemic area, in which it's very difficult to balance the protection of health and the development and well-being of anyone. But we tried in the past to pass this concept and to manage in a prevention way the determinants of climate and environment into health. There is a very nice initiative from WHO that gives the health advocacy for to give message to policy and to citizenships around the role of environment and climate on health. So also to try to propose strategies. In this document, that is the country climate and health country profile, the integration could be the first integration for prevention could be the basic concept in a nutshell, because we expanded this concept into many different areas, but the aim is the same, is to provide a best practice of integrating not only information but also strategies. And Italy could be really a laboratory in this field, because it presents quite all the climatic drivers that are present in our planet. And as an example, but just in a picture, we propose in this country profile the political action that could prevent waterborne diseases, but also to push for sustainable development, starting from the climatic and environmental drivers in water resources, taking into account the current and future scenarios in the water sector. The results of this was to present a strategy, and the message I want to give you is that with the integration of data information and with the intersectoral and interdisciplinary comprehensive approach that Stefano just presented before into your regional project, we can do many important things, or many important proposals. Okay, we tried to pass this concept in our proposal of recovery plan, Next Generation EU, because starting from our experience, we try to design a new structure in institutional architecture, try to combine environment and health. The concept is that now the health is the last step after in many let me say tragedies, like in the case of PFAS in Veneto, because there is more development and economic growth, then it could be an environmental impact, and the last step is health impact. That is also difficult to understand, estimate, and assess after many years, after tens of years. But our willingness is to move health together with development, to sustain development without damages for our next generation, our daughters and sons. So from passing in a practical way through green transition, through digital transition, from recovery, remediation, or response in a world emergency to prevention. And this message is already clear in the 2030 vision by WHO, that is perfectly agreed with the Ostrava conference and the UN SDGs, that health should be a leader, and not to determine, but to understand and sustain the other sector that has relevance to health, environment, and climate in a way that is protective for health. So the actions from for the health institutions are lots, and as you can imagine, cover air, cities, children, and lots of things that are the core business for health. But health should also have an added value, a strong value, in acting with other institutions that can determine health from their side. So in our proposal, we are trying to pass from the proximal level that you are explaining in the Phoenix project to the distal concept at the central level, by having a very close cooperation and exchanging of that data between health institutions and environmental institutions, but not only, and from regional, local, regional, and central systems, but also as Victor maybe before questioned in a European level, at the European level. So we have also to invest in infrastructure and to try to put in our territory this kind of cooperation. But this project is a very nice example of this. So what kind of data we are talking about? Lots of data. This picture I just trying to put here some ideal collection data warehouse, and you can imagine that we are starting from health data, and if we talk about environmental data, we could include everything, such as the use of soil and many other information that should be handleable. And in the center, the role of ecosystem and its measure could be more than expected useful. So to go to the conclusion, we have a very clear the concept of One Health, and this pandemics is giving another example of how important it is to combine, to join the health of animals, humans, but also natural environments. But we should think the same for water, because if we think to the water cycle, it's clear that now, and this brilliant paper highlights that we could not yet conceive the water cycle as a natural, as we are teaching to our sons and daughters, as a natural system, a natural cycle, because within this natural cycle we are in a stable way putting our cycle, the urban water cycle, and the pressure we are having in climate, land cover, and water use is yet stable into this water cycle. So the concept is to, if we have One Health, we should think as the one water. We couldn't spread the competencies, data, information, and actions amongst territories, different territories, but also among different sectors. Urban wastewater, bathing water, drinking water. Water is one for life, and this concept was understood in the water policy, because we passed from a step in which there were many water acts tried to follow specific problem, nitrates, urban wastewater, or also water for shellfish production. But it was understood in 2000 that we needed of a consistent and comprehensive policy in which the Water Framework Directive should play the core role among the many objectives of protection of water. We are here just presenting 3 objectives, but we could think to many other objectives and aims around water. And this concept is now translated into facts, with water safety plan, with the interaction amongst the directive. So what we can do to finalizing my presentation with the Drinking Water Directive that was just completed in the last December, that the limit for PFAS that we have now in directive is just a parameter. Is just a parameter that is just an objective. Is not the core protection of our life for PFAS or for many other emerging contaminants. It is just the last check that everything we designed before is functioning. And what we need before? We need of articulate, of a safe environment. So the basin authority should play a fundamental role into, but we already saw this by Gisella before, the role of use of soil, of industrial production, of wastewater monitoring in the soil to protect catchment. From that point, we should manage the risk assessment and management of the supply system to treat or to also for wastewater treatment. At the end, we have a risk assessment of domestic. But beyond this, we need of a new global strategy that is the strategy for sustainability, that in case of PFAS that are also important for industries, for development, for our health from other point of view, not only because they are used also in clinical and in medical applications, but also because the life of many industries is related to the use of chemical compounds. So we should be sure that these chemicals are sustainable for life, and to do this, we should be very ambitious, like the EU chemical strategy wants to do. So thank you for your attention.
Thanks, Luca, for this interesting presentation, and I pass the floor, if there is no question specific to you, sorry, to the next speaker, that is Xavier Dochy from the ANSES, which is the corresponding National Health Institute for Protection Health for France, from the title PFAS Screening in France and Source Identification for Human Exposure Assessment. The idea of this short webinar was, of course, to share experience from this kind, from other institutions. I have to habilitate Xavier to share the screen. Sorry, one moment. Dochy, I was looking for where is Dochy Xavier. Okay. Okay. Okay, Xavier, are you able to share the screen? Okay, perfect. We see that.
Good morning, everyone. Thank you, Stefano, for the introduction. So I work in the water chemistry department of the Nancy Laboratory for Hydrology. This laboratory belongs to the French Agency for Food and Environmental Safety, and we worked for 10 years on PFAS in surface water, groundwater, industrial wastewater, sludge, soil, and drinking water. So with this presentation, I'm going to briefly show what we did on the topic of PFAS in drinking water in France, what we learned on point sources, and what gray areas remain. In 2009, we carried out a national screening study on 10 PFAS. This campaign was requested by the French Ministry of Health following the finding of a huge contamination in Germany due to waste material applied to agricultural land. What is a national screening study? In France, there are 30,000 surface and groundwater resources and 27,000 drinking water networks. As you might guess, it is not technically possible to sample all of them. So to tackle this problem, we developed a particular sampling strategy. France is divided into 100 departments. For our national screening studies, we collect raw and treated water samples on 3 sites in each department. The first site is the resource producing the greatest flow in the department. The second site is randomly selected, and the third site is possibly affected by releases due to industrial or commercial activities, thus increasing the likelihood of detection of the targeted contaminants. In total, 300 raw water samples and 300 treated water samples are analyzed during a national screening study, representing approximately 20% of the national water supply flow. The overall results are shown in the following table. But to locate the main point sources, we have to look at every result in depth, especially those with specific profile pattern and those with the highest PFAS sum. Hence, our attention was drawn by particular PFAS profile patterns along the Rhône River. The profile pattern, PFHXA, PFNA, PFOA, was observed at 6 sampling points in this river, covering 200 kilometers. None of the other samples collected in France exhibited this profile pattern. Further investigation led to the discovery of an industrial site involved in the fluorotelomere production and the manufacture of fluoropolymers and fluoroelastomers from the beginning of the 60s. 15 kilometers downstream from the industrial site, the total PFAS concentration in the treated water was above the parametric value proposed in the next EU directive on drinking water quality. Broadly speaking, profile patterns are helpful clues to identify the PFAS source. Based on our experience, a mix of short-chain PFCA with or without PFSA likely comes from a firefighting foam use. Specific PFAS, such as PFNA, 6,2-FT-AB, or GenX, are also strong evidence of some activities. Now, the highest PFAS sum. The highest PFAS sum was recorded in a well located along the Oise River. Further investigations led to the discovery of an industrial site involved in the fluorotelomere production. The fluorotelomere mass loadings discharged into the Oise River ranged from 1.6 to 7 kilo a day. Downstream from the industrial site, the raw water of the 3 closest drinking water treatment plants were contaminated by PFAS, and some fluorotelomers were even detected in 1 tap water sample. The sites where the second and third highest PFAS sums were recorded, turned out to be sites where firefighting foams were used. At that time, this kind of activity was quite overlooked in France. This experience and publication on this issue drew our attention, and we located the main firefighter training center in France. And after investigation, a well, not included in the national screening study, providing drinking water to a medium-sized city has to be closed. We also tried to use data of another study to locate main point sources. In 2011, a study was conducted by our agency to measure PFAS concentration in river fish. The goal of this study was to assess the exposure to the French population through fish consumption. Since some PFAS are bioaccumulative, we thought that this study could help us to find other point sources. And we found 2 locations where PFAS concentration in fish were high compared to other sites. So we collected water and sediment from both locations, but we did not detect any significant PFAS concentration. We think that the trouble with fish is that they move. For instance, high PFAS concentration were observed in fish collected from a Rhone tributary close to the fluoropolymer manufacturing facility, and we think they were contaminated during stays in the Rhone River. At the beginning, we only analyzed 10 PFAS, and we quickly understood that it was not enough to identify some point sources and accurately assess the PFAS concentration in water and the subsequent exposure. So we first increased the number of PFAS we were able to detect and quantify. And at the end, we were able to analyze more than 50 PFAS. 2 examples of the interest to widen the scope of target monitoring. In the Rhone River, the profile pattern, which helped to identify the industrial site, was PFHXA, PFNA, PFOA. But after many investigations, it turned out that significant amounts of 2 other PFAS were also discharged into the river, 6,2 FTSA and PFUNDA. Second example, in a well located close to a firefighter training area and used to supply drinking water, we found several PFCA. It was not surprising, but also 6,2 FTSA and above all 6,2 FTAB at 5 micrograms per liter. Then we started using surrogate parameters like AOF and top EFA. They are interesting but somewhat frustrating methods, because you can see that you are sometimes missing some PFAS. Moreover, they are not very useful for health risk assessments. For instance, despite analyzing dozens of PFAS, the percentage that could be attributed to targeted PFAS was only 35% in the river sample collected downstream of the discharge pipe of a training center for firefighters. Another example, for both AOF determinations and top assay, the percentages that could be attributed to targeted PFAS range from 11 to 106% in the raw effluent of a fluorochemical manufacturing facility. Regarding high-resolution mass spectrometry, we have a little experience on it, and mainly with a few foam concentrates. But based on a recently published study, it seems a complementary tool in the PFAS monitoring. In France, I do not think we have finished dealing with PFAS and their main point sources. It is likely that in the future, other highly emitting sites will be found. In the USA, hundreds of sites where firefighting foams were used, especially military bases, are under investigation. And that's surely, in my opinion, a smart move to follow. Former facilities which used or produced PFAS in the 60s, 70s, and 80s are now really hard to locate, but their environmental burden is still present. Some industrial activities using PFAS, less known and less investigated, such as electronic industries and facilities involved in surface protection application, merit also more attention. The PFAS emissions are likely lower than those observed in the case of fluoropolymer plants, but they could have significant local burdens. Moreover, many companies dumped the solid waste and sludge from their PFAS manufacturing facilities to landfills. Throughout the world, we have now many examples of these landfills leaching into groundwater and entering the environment. They are also really hard to locate, but should not be overlooked. And to complicate the tracking, solid waste was sometimes shipped away from the production facility, and in some cases, they even crossed the borders. To conclude, by just taking into account the issue of the tracking of the main point sources in a country, the answer to the following title of an article published in 2017 would be definitely yes. Indeed, a week ago, we located a new PFAS emission site where at least one well used for drinking water supply is PFAS tainted. Many thanks for your attention.
Thank you, Xavier, for your clear presentation of the picture of a very large screening in a very large country, because France is very large. And it's very interesting that the characteristic of PFAS that they have multiple sources. Of course, it is very hard, yes, to uphill to find all the sources in the territory. If there are no questions in the chat, I pass the floor to Eric Verbrucken from the RIVM, that's the Netherlands agency for the environment and that, and for a presentation about the PFAS in the Netherlands, new challenge and the developments for risk assessment. Thank you, Eric. Okay, we can see. we see the.
Yeah, now I'm unmuted. Yeah, I think this works. Okay, thank you very much, Stefano, for
the presentation. Echo, we see.
Can you hear me as well?
Yes, we hear you, but we see only your. Okay, you are.
You see my login screen now, but you don't see my password, so that's okay.
Perfect. Now we see. Okay.
Yeah, it works. Okay, good, fine, thank you.
Thank you.
Okay. Well, my name is Erik Verbrugge. I'm from the Dutch National Institute for Public Health and the Environment. And I will, in short, tell you something about what we have done on PFAS in the last couple of years, actually. First of all, a little history of PFAS in the Netherlands. And actually, the history is not that long. I realized that it's only 5 years, I think, that PFAS really were in the attention of the public and the policy. I think this all started about 5 years ago when there was an article in a news magazine which was actually summarizing the situation in the United States with the production facilities over there, and asked questions whether or not this could be similar for the Dutch production facility. And that was, I think, in the end of 2015, and this raised a lot of public awareness. And from that, there were some questions asked in the Dutch Parliament, and that triggered again a lot of actions further. So then PFAS was indeed detected in the area of the production facility, and this was especially PFOA, so used in the past for the production of Teflon, and later on also the AFPO-DA, the well known as GenX, which was the replacement chemical for PFOA for the production of Teflon. So these findings triggered a lot of research into the occurrence, but also in the hazard of these substances. And finally, I think from that, a lot of regulatory actions followed. And these were, for example, on GenX, on AFPO-DA, and also on permits that were given for the production facility. I will talk about some of these research and regulatory actions now. First of all, I think what I said, GenX, that was a very well, that was maybe the most emerging chemical in the Netherlands. It was used at the production facility, and it appeared to occur in quite high concentrations in the aquatic environment around the production facility. But also later on, it appeared to have been spread by air, and so it also was in not only in water, but also in kitchen gardens, for example, and in dairy products. So a lot of research was spent to look at the occurrence in water and soil. And finally, it was observed that this was not really limited to the area of the production facility, but also logically downstream of the production facility, but also upstream. And for example, here in this plot, that is, you see a big red dot over here, which is completely a different location from the production facility where all the orange spots are located. And this appeared, for example, a Teflon processing facility, and that so the production facility moved the Teflon to this processing facility and then back again. And here there was a lot of emission as well. So the sources contained not only the production but also the processing, and later on it appeared that also waste processing was a kind of emission source. But what was also very interesting is that it's not only local point sources, but there appeared a lot of diffuse sources as well, which remained largely unknown. What is the source of the chemical over there? So this was all about GenX, AFPODA. Also, other PFASs were investigated, of course, and a lot of attention has also been paid to PFOA, because that was the precursor of the precursor. I meant the chemical that was used before AFPODA. Risk assessments were especially focused on local situations. So, for example, the drinking water in and around the area of the production facility, but also at other hotspots. And not only the current state was investigated, but also the past and the future distribution of this chemical by modeling. For example, modeling within the riverbank filtrations. Also, the vegetables from kitchen gardens were investigated, the occurrence of PFAS in dairy products, and also the risk arising from swimming, for example, in water contaminated with PFAS. Well, first of all, we had an interest in AFPODA because it was already on the list for 2017 of the Community Rolling Action Plan on the REACH. This was an entry together with Germany. So we, with the UBA, we wanted to look further into the risks arising from GenX. There was a concern for the persistence, the PBT, the persistence, bioaccumulative and toxic properties in combination with a wide dispersive use. And this was based on the similarities with PFOA. PFOA had already been identified as a PBT substance back in 2013. And GenX had similar use and also structural similarities to PFOA. And then, later on, we noted the high concentrations in water in the Netherlands of this chemical, and so the substance evaluation became even more important for the Dutch government. So in the end, we requested data for the PBT endpoints on the carcinogenicity of the chemical, because we think that there is a concern for carcinogenicity, and also for the human toxicological half-life, which is for PFAS substances good measure of the bioaccumulative properties. But yeah, the substance evaluation is actually quite often a very time-consuming process. So the decision on the substance evaluation was from 2019, February, no, actually 2 years back. But what you see is that with all kind of processes going on, so the registrant went to the Board of Appeal, that there is no information yet. And actually what you see here is a screenshot from a newspaper from this Monday, where it says that the registrant has to do now the research because nothing has been done yet. So at the same time that this substance evaluation was taking place, I think there were discussions in the ECA-PBT expert group, of which I'm a member too, and I think there were discussions going on whether PMT substances which have a combination of persistent, mobile and toxic chemicals, whether they are equally of concern as PBT or CMR substances. So within REACH you have this category 57F, which is equivalent level of concern to these substances. And by then, I think Germany was already quite active on the PMT area. For example, PFASA, the hexanoic acid, was already considered as a potential PMT substance. And we were thinking in the Netherlands whether this could be applicable to Genix AFPODA as well. So in the end, we got a support of the ministry to go further with this SVHA dossier for the substance. And that started in 2018. And actually, already in June 2019, the SVHC dossier for Genix was adopted under REACH, which made it the first substance that was actually classified as equivalent level of concern based on its persistent, mobile, and toxic properties. This now has been followed by another perfluorinated chemical, which is PFBS, that was done by Norway. And also the German substance PFASA is now, there's a restriction dossier in preparation. So the concern of these perfluorinated chemicals for the PMT-like properties that is now getting more and more attention and also being incorporated in the risk assessments. In general, I think the PMT as a hazard classification is also getting more attention. UBA is already busy with it for several years to propose these kind of substances as PMT. And also now the European Commission has the intention to classify PMT substances as substances of very high concern. In the Netherlands, we are busy with PMTs as well. So we actually do a kind of screening program where we do a lot of QSAR modeling and try to pick out PMT substances from large databases and compare that with substances that occur in surface water that is meant for drinking water extraction. Do that together in the cooperation with drinking water companies. We try to develop that every now and then, and we're now quite well advanced in also assessing the toxicity of these kind of substances based on QSAR modeling. So next to that, I think there's also now a REACH intention for a broad restriction of PFAS, and that is a restriction dossier that is prepared by a lot of member states. The Netherlands is also active part together with Denmark, Germany, Norway, Sweden, and ECHA itself. And this is focused on actually on the whole group of substances, because we, from a regulatory point of view, you don't want to get the old PFAS being substituted by new PFAS and start every now and then again with the whole assessment, but make a restriction proposal for the whole group of substances. And this is actually based on a concept that where persistence is quite central. So all these PFAS substances are really very persistent, but next to persistence, they have also the properties either bioaccumulation or mobile, or even bioaccumulative and mobile at the same time, for example, PFOA. And next to that, they are toxic as well. They have all kinds of toxic effects. beside that, this is the risk assessment and the hazard classification, but also we need qualitative measures for all kind of policy goals, some local or national. For example, in the Netherlands, we have a temporary framework of enforcement for PFAS, and this is mainly focused on what to do with the transport of soil, construction sites, and that kind of stuff. But also, for example, for permits for the emissions from soil remediation and or water site remediations and so on. We need to have quantitative measures. And I said here qualitative, but of course it means quantitative. I'm sorry for that. So the risk assessment of these polluted sites that I already mentioned, fish consumption or kitchen gardens, they all, if you need to know whether it's safe or not, you must have a quantitative measure, and that is also true for drinking water. Until now, these assessments have mainly focused on 3 chemicals, which were PFOA, PFAS, and again AFPODA, generics. And there are several levels of standards. For example, the human-based guidance values, the toxicological daily intakes, and so on. Drinking water standards have been derived, but also environmental quality standards for soil and surface water. Sometimes they were assigned as preliminary because we didn't have that much information, but I think for some others we had quite some information and we could do a full assessment. For example, not only on ecotoxicity, but also on secondary poisoning, so the poisoning of birds and mammals that live in the food chain that is dependent on the soil or surface water, and also the human fish consumption, which is also directly related to the human health-based guidance values. So these are documented in a series of reports from RIVM now, which can be retrieved from our website. And there the quality standard derivations are explained. But we have now many chemicals, and not only these 3 PFAS. So we also developed a kind of system in which other PFAS were scored against PFOA. So we derived relative potency factors that are actually comparing the relative toxicity to a standard for which you know quite a lot, and the standard then is in this case PFOA. These relative potency factors were developed from an effect from toxicological studies in rats. So this all 28 or 90-day toxicity studies in rats, and they are based on liver effects. And what we do with them is actually to apply the relative potency factors to the human health-based guidance value for PFOA and scale so the health-based guidance value for PFOA to a value for another PFAS for which you know quite you have only a few data. Of course, this is not that straightforward, and for example, recently the EFSA has published an opinion on health-based guidance values for humans for 4 PFAS. This is based on epidemiological studies, and the endpoint in the end is an immune system effect. Nevertheless, we think that it is possible to scale these kind of effects on the basis of these relative potency factors, of course with some you must be a little bit careful with it, but it's best, I think, that we have at this moment. This can be used to derive quality standards for a lot of chemicals, actually. And we were also thinking that the Water Framework Directive now requires that an EQS is derived for the group of PFAS, and that might be a way out for this group as well. So we are exploring whether this can be used for the Water Framework Directive as well. But these discussions are still going on, and that's actually what I wanted to conclude with. All this is still work in progress. Of course, the restriction for the group of PFAS that's started this year, last year actually, and should be, well, the first results should be completed, I think, next year somewhere. Also, the relative potency factor approach, we have a first publication that ready now, but there's still some work done on whether this can be extrapolated to other effects on internal body residues and so on. And in combination with that, the development of an EQS, for example, for the group of PFAS under the Water Framework Directive is very interesting, I think. And another area of development is the development of general criteria for the PMT substances and how to deal with them in risk assessment. What I also shortly mentioned is this EFSA opinion. So the EFSA opinion was published in last year, and actually it yielded some human-based guidance values that were quite low, and we are also thinking whether this needs the potential revision of the risk assessment that were done in the past are needed in the Netherlands for example, these local specific risk assessments. And with that, I wanted to conclude the presentation. Thank you very much.
Thank you, Eric, for your presentation. There are two questions for you. One is from Brambilla, Gianfranco, ciao, from ISS. He told that RVM follows health risk assessment for PFAS quite different from that of EFSA and based on relative potency factors. A comment of this, please. You of course have already reported on that, but we can add some comment how to deal with this very low, how can we fit your relative potency approach with the EFSA limits that are very low and very difficult?
Yeah. The low is not the point. I think the point here is that EFSA has been taken 4 chemicals and considered them as one, actually. We have been thinking about this a lot, actually. We have also a document ready now in which we explain how we would go on with the EFSA opinion in combination with this relative potency factor approach. And actually, as we are now, we think we would apply the EFSA opinion as it was for as it were for PFOA, and apply the relative potency factors to the EFSA opinion value. So that means that if you have a relative potency factor for PFBA, which has a relative low toxicity, the health-based guidance value for PFBA will be accordingly higher than this EFSA opinion value from the EFSA opinion, and the same but the other way around is for substances that are even more toxic than PFOA. So actually, we take the EFSA value, and the relative potency factors are only relative to this value. So and we set the value for EFSA as were it for PFOA. That's actually how we want to go forward with it right now.
And the second question is about the definition of short chain PFAS. That's something that looks like to be not so important, but maybe can have some in the mobile definition, some implications in the mobile definition.
Yeah, there were already some remarks in the chat, I think, and what you say is indeed, it's maybe not that important because it's a continuous scale from short to long chain, and from mobile to very bioaccumulative and everything in between, I think. But in general, I think we see from those substances that have 6 perfluorinated chemicals to 5 perfluorinated chemicals, there seems to be a quite shift in especially in toxicokinetic behavior. So if I have to say what is short chain, then I would say everything with less than 6 perfluorinated chemicals is short chain, and everything with 6 or higher perfluorinated chemicals is perfluorinated carbon atoms is long chain. So that means PFAXS and PFHPA would be long chain, and above, and everything below would be short chain. But this is a matter of definition, and actually it's, for example, for things like restriction processes and so, not even that important, because we think there's an overlap between the long and in the properties of the long and the short chain chemicals.
Thank you, Eric. We arrived at the end of this interesting, I hope, days. I have.
And sorry, Stefano.
Okay.
Maybe there is one raised hand.
Okay.
From Jeff.
Yes.
I don't know if.
Do we? Yes. Can you hear me?
Yes, you can hear.
Do you hear me? Oh, super. Do we have time for one more question?
Yes, of course. We are not.
Super.
I don't know
Eric.
we have time before eating.
Right. Sorry, Eric. Maybe I missed it, but well, yes, the drinking water directive and the EFSA, quite different approaches and quite different levels. Can you comment on the how you see those two comparing to each other?
Yeah, that's a difficult question, because actually it's 2 European agencies, the Commission and EFSA. But yeah, I think you're right. So the EFSA opinion is from a later stage than the drinking water directive, although the drinking water directive has just been implemented a year ago. But you're right in the remark that it's the EFSA opinion has a much more stringent and lower health-based value. Indeed, that's true. I think yeah, at least one thing is apparent, that is from the drinking water directive, that indeed some chemicals, the short chain ones with the PFBA, PFAXA, have less toxicity than the long chain, and that is, I think, correct. And the EFSA opinion looked especially at food and so on. while with drinking water you are maybe more exposed to the short chain PFAS. But that's it would be nice to have them all in one kind of assessment scheme framework, so to say.
Thank you.
Yeah.
Okay. Any other question? No. Okay. I don't want to stress you with the final remarks. Okay. I only say that it's very important to manage the PFAS problem, have ongoing wide screening programs, because if you find PFAS in Veneto was because we have a screening program across Italy, but this screening program should involve all the possible environmental compartments, because they are diffused in air, in soil, in sediments, maybe some kinds of waters. And because the characteristic of this PFAS family are so wide that we cannot include only as a short chain, long chain, PBT, PBM, PMT. They cover all the possibility of the physical chemical range of the contaminants. That's very important, that there are the need for non-target monitoring, for as we've seen from Xavier, also from a specific methods of analysis, like the oxidative persulfate, the method for oxidative bipersulfate. And also the problem is that all this data should be integrated in a screening data approach with the other data, and sometimes we have not for all the compounds data available, and that's also, it's very important that we need also from predicting toxicological properties, so we need also very reliable system to predict the toxicological properties. And then the next webinar we have as an host Professor Benfenati from Mario Negri, that will show us the progress of the CUSAR models for PFAS. And of course, from our project, that we understand that tackling complex problems require complex working methods, what the collaboration, sharing data, cooperation within a formal institutional framework and with sharing data. It's a clear fundamental. And also that if you want to be prepared to face a pollution event, we have to create before a stable multidisciplinary group of people working on the information system, collecting data, expert, and involve also data providers. And all the data providers have to share the data, and it's important necessary for risk assessment exercise. And this data sharing will be included into the scheme of water safety plan. So water safety plan can be a way to share data, to be prepared, to be ready for the pollution events. And what else? There is an activity. It's very important, the possibility to integrate our project within the large cooperative program that called Partnership for the Assessment of Risks for Chemical, that the so-called PARC project led by ANSES. That's after this need, and of course I was astonished from the large audience, more than 100. I feel me as the Blues Brother when they fill the hall, the concert hall, and I want to thank you for your active participation, and see you on next Wednesday. Thank you for all. Bye. Giselle, I want to say something, Vanessa.
Just many thanks, Stefano, and thank you to everybody.
Yes.
Thank you.
Thank you to everybody by Veneto Region. Thank you very much.
The next time we'll invite them to Venezia, all of them as a free ticket for Venezia.
We hope, Stefano.
Yes.
Thanks
We
for
are
having me
lucky for this kind of in-presence meeting. Thank you for your participation.
Thank you. Bye.
Bye-bye.
Thank you. Bye-bye.
Aspetta, no, è recording. Interrompi.
Bye bye.